Hi everyone. We're going to do a quick example of the housing data set from our textbook using RapidMiner. So let's quickly, before we go into RapidMiner, let's quickly review the steps that we want to go through. First of all, we want to define our business opportunity. Defining this business opportunity allows us to understand what sort of data are needed and what our task is. So is it a prediction? Is it a classification, estimation? Is it a segmentation? We won't know that until we clearly define what our business opportunity is. Once we define that, then we go out and find the data that we need to complete these tasks. And we come up with a list of attributes or possible attributes for analysis and where to go find them. Once we get the attributes, we have to clean the data. And this may be filling in missing values, looking at outliers. The next step is to transform the data. We could take the data and maybe normalize it. We could create dummy variables in the case of attributes that don't like categorical values, or in the flip side of that, maybe some algorithms don't like continuous data, so we might bin the data. We then select our attributes. It's also known as feature selection, and that might be getting a subset of the attributes that are helpful for the data. We partition the data. As you may remember, we take our entire data set that usually contains a large amount of rows. We could initially sample just to make the sample smaller, but then once we decide on the data set we're going to use, we're going to split the data set into two subsets of data: training data and test data. We will train our model on the training data, and then we will test it on test data. We do that to make sure that we don't overfit. That means that the algorithm could find some quirky, perchance, correlations in the data and fit too closely to the attributes. So what we want to do is make sure that we test our models that we are creating on data that it wasn't trained on. So we train various models on a trained data set, and then we validate. We have models to validate. We validate those models, and those models we create some metrics for those models, and we compare those metrics for all the different models. And from there, we pick the model that's the best model. Once we've selected the best model, we apply that model on a new data set without filled in values. So in this particular case, the business opportunity has been defined for us. We want to try to create a model that estimates the value of a home based on a series of attributes. The attributes have been given to us. The data are pretty clean. There's no missing values or outliers, so we can skip that step. So we're actually going to start on step 4. There is one nominal value in the data set, and we are going to change that particular attribute to a series of attributes that are dummy variables. And we do this because we're running a linear regression, and linear regression will not take categorical data. We're going to skip the select attributes. We're going to use all of them. That's because in the future, we're going to spend quite a bit of time talking about selecting attributes or features. The next step is to partition the data. What does this mean? This means we take our data set and we split it into a training set and a test set. So we will do that step. We're only going to train one model, and we're going to look at the metrics that come out, and that's where we're going to end this particular exercise. So let's bring up RapidMiner. And we're going to actually just close this. We have a brand new process here. Let's talk a little bit about the interface. On the left-hand side, you have what's called the repository. This is where I can store my data. So I have some sample data that I can play with from RapidMiner, also some sample processes, templates, which are useful. There are different common tasks, so it has templates on how to do this. And then it has some tutorials, which I really highly recommend you do. Then we've got my local repository. That's data and processes that are living in my computer. However, if I'm logged on, I also have a cloud repository. And this is handy because no matter where I'm at, if I log in and I'm using a version of RapidMiner, say in the lab and not on my computer, as long as I'm logged in, it's going to find this stuff. So I suggest in your case for class that you use the cloud repository so you can go back and forth between your laptop or computer at home and the computer in the lab. Okay. Over here we have what are called the operators. Operators basically complete tasks. So the process that we outlined here, pretty much every single one of these matches one-to-one to the operator folders and the various tasks that we do in data mining. When we pick an operator, we have the parameters for the operator sitting on the right-hand side, and a very helpful process help window that describes exactly what that operator is doing. So in this case, all we have up is the process. It's describing to us what a process is. So you can read about a process and then find out what some of those attributes up here, those settings up here mean, the parameters. Okay, so I could add the data to my repository, or I could just bring it in through an operator. In this case, I'm going to show you how to bring it in through an operator. And in the future, I'll show you how to store it in your repository. So we're going to go to Data Access, Files, Read, and we're going to read an Excel file. You know, in the case that I didn't feel like digging, by the way, I can just type the word, and I can find the attributes of the operators pretty easy without having to dig through the folder structure. You see that I have a little exclamation mark. If I click on it, it says, hey, you haven't told me exactly what you're doing, where the data are, and where the Excel spreadsheet is. So I understand. Also, I can look over here. When I bring the exclamation mark, it shows me here's where you need to set that parameter. So a lot of hints. You'll also note at the bottom some recommended operators, which is super handy. Because RapidMiner runs in the cloud, it's able to collect data of people running different processes and then submit percentages of in what order these operators are used. So it suggests to you what you may want to use. Also, you will see wisdom of the crowd here. So for example, if I click down here, it tells me that 82% of the people chose not to use the first row as names. I'm going to use the import configuration wizard, basically because it helps me define the data type and role. I've created in my RapidMiner structure, I've created a shortcut to where all the data sets from the textbook are. So we'll go over here and we are going to pick the West Roxbury dataset. It opens with a warning, right? It tells us here, we're here to help you import your data, but be careful, an Excel file can contain multiple sheets, so import the correct one, right? So actually the first tab are metadata. We don't want to import those. This is useful. So we see that we have the total value of the house, which is what we're going to try to estimate, tax, square area, floors. And then we have one variable that is going to be categorical, which is when the house was remodeled. So we click over here on data, and these are the data that we're going to use to build our model and test our model. We're going to skip this step. You have the ability to annotate a row. We'll talk about that later. Okay. I can tell it, hey, guess my value type, which is great. As far as I can see, it did well. Total value, though, is an attribute, but it's also one I want to estimate. So I'm going to change that to label. That is what I'm going to use to estimate. The rest of them look right. And you see that remodel, unfortunately, it uses the word polynomial when to mean a value that is text. So we leave it alone. We could argue that floors, rooms, bedroom, full bath, half bath, kitchen, fireplace should actually be nominal, because there's no such thing as half a fireplace. But for now, we're just going to leave it alone. Later on in class, we will get fancier and start to really look at each attribute and how it should be defined. So I say finish. So what's happened now, I want to use first row names. Look, it's filled in everything for me. Sheet number 2, this is the range, and I want to use the first row as name, okay? So basically what's happening now, there's nothing coming in here because this is the data are being read by an operator. But what comes out, if I hover over the out, it's not wanting to do it. Okay, then I see that the output is a data table with the data that was imported from Excel. If I want to take a look at it, notice that I have 2 tabs here, design and results. Whenever I run an operator, if I connect it to the results tab over here, what happens is if I run it, the results show up in the results tab. So let's run it. And you note that the results are basically the data imported. Notice it's colored our label in a different color, okay? Because it knows that it's not to use that attribute to build a model, but rather to train and then to test it. We like to take a look at our data. This is one of the features of RapidMiner that is my favorite. If we push on statistics, we see summary statistics for each one of the attributes, including the min, the max, the average. We can also click on the down arrow and we can visualize this information. And if we want to see it even larger, we can open the chart itself and see it here. And we can mess with some of the things in the chart and say we wanted to change the coloring or take a look at its correlation to something else. But the summary statistics are very useful. And it does that for every single one of the attributes that you have brought in. And notice it gives us histograms for the continuous variables, but then we have a frequency chart for our categorical variable. Back to our data, and let's go back to the design. I'm going to erase this because we have some more steps to do. In our next step is actually to transform the data, and we were going to transform the categorical variable of remodel to a dummy variable. How do we do that? Well, after we access the data, we do some data transformation. This is under blending. We want to transform an attribute, and we want to transform the type. So we want to take a variable that's nominal and change it to numerical. And if we highlight over this, it says maps all the real values, usually simply using the internal indices, right? So we're going to go nominal to numerical. What's coming out of this is the actual data set. We need to feed it forward. Okay, now it's happy. And if we highlight the operator, it's saying, what do you want to do? I want to change a nominal to a numerical. It says which type. Most people say all. That's the default. If we say all, we will be fine because there's only one categorical variable, so it makes sense. It also would make sense because if we want to run a regression, we want all our nominal variables to be numerical. We can also select one, so single, and it says what attribute, and actually we only have one option, which is remodel because there's only one. Okay, so I'm going to connect that to the results window and run it and see what happens. Notice I now have 3 new attributes. Okay, and basically it's now created 3 dummy variables that I can use for my model. Let's go back to our design. Can I remove this? What is the next step? We decided we're not going to do a feature selection for now. The next step is to partition the data into a training set and a test set. And then on that partition data, we will train a model and then validate that model. Well, all of these steps, 6, 7, and 8, happen in one operator. in RapidMiner. And it's an operator that has a series of sub-operators or sub-processes. And it makes it very clear for you. So let's go do that. So I'm going to close here, and I'm going to go to validation. And I want to do a split validation. Why split validation? I'm going to split the example set of the data into a training and test set so that I can validate a model. So I'm going to drop that here. In comes the data. Still has an exclamation mark because I am not done defining this. It's asking me what's the split ratio. We could train on 70% data and validate on 30. Let's say we want to do 60% training, 40% validation. This is somewhat arbitrary. It depends on the size of your data. When I see this this figure here in the corner, what it's telling me is this operator has a series of sub-operators. And if I double click on it, it brings me to the sub-operators processes. If I want to go back to my process, I come here. So here I am, and it makes this very, very clear. It says on this side, you're going to train the data, train the model. On here, you're going to test the model. The data coming out here are the 60% that we set aside for training. So this little stream here is going to bring out all the training data, and we're going to spit out a model, which is basically a function, okay? In the testing window, we're going to bring in the model, or the function that is to be applied, and the test data. And that test data, we are going to apply the model to it, and we have the actual value of the home. So we will estimate the value of the home and look at the predicted estimated value of the home and the actual value of the home, and it's able to calculate a metric, which is an error metric. So let's start by training a model. So we go over here to modeling. What we're doing is a prediction, and it's a function, which is linear regression, okay? We drop it here. Notice how many different functions and models and algorithms we have. We have tons to try, but for now, we're just gonna try one. So basically here, I'm bringing the training data into the linear regression. So now it has data to train a model. And what comes out of here is the actual model, okay? Over here now, I need to apply the model. And look at here, recommended operators, 100% of the crowd has used apply model here. So we can feel pretty confident using apply model. We bring in the model. This model is coming from this side. It's the trained model from our test data. And we're going to bring in our test data. Okay, so now it's got a function that was built by linear regression on training data, and it's got test data to apply that model. But we don't want to just apply that model, we want to calculate an error so that we know how well that model does. So when we come over here to validation, I'm sorry, not validation, we need performance. Where is it? Oh, there it is, performance. Well, and actually it's suggesting it to me down here. So we want performance on a regression. We push forward our labeled data. LAB stands for labeled data. And we want the performance to come out of here, okay? So we're going to tell it to use root mean square error as the main criterion. And we can ask for other metrics. For now, we'll just stick with root mean square error. So basically we're done. So what did we do? On one side, we ran a linear regression and created a model. On the other side, we took that model, tested it, and then we labeled the test data and calculated the difference between our estimation and the actual value, row by row, to come up with a performance metric. Let's go up to the process. And now we are back to the validation, and we need to see some results. So we can push forward the model that is going to give us the, oh, there's something I wanted to do. Hang on, within this, in the linear regression, I want to use all, no feature selection. What does that mean? I want to use all the attributes because I don't want it to cut down on attributes. And we'll talk more at length about this. So our model comes out. We can bring forward our data so we can see what it looks like. and then our metrics. Okay, and we should be done. And if we have any issues, it'll tell us with pretty clear descriptions. So off we go. Okay, so it's reporting our root mean square error. That's our performance. And it actually tells us exactly what the root mean square error is, which is pretty low. Had we run more than one model, we could compare that metric and pick the metric with the lowest error. Here's our data set. And here's the actual function. And what it's giving here is the beta coefficients to our linear regression. And if we wanted to look at it, it's actually a formula, right? So these are the weights that are given, and each one of those values is plugged in for each row to calculate the labeled data. And that's basically it for this simple exercise. I hope that you try this at home a few times so we can get fancier in the classroom next Wednesday. Thank you.